Hi! In this lesson I'm going to talk about wavelength, frequency and energy of light. Okay, so what is wavelength? Well, can you guess what is a wavelength? Looking at that drawing, will it help you now? You're right! Well, wavelength is just simply as a distance between 2 points. That's wavelength. So that's a wave in here. But where's the wavelength? You're right. From that point to that point, it is called a wavelength because it's the distance between that's 1.1 and that's 0.2. What about here? If we take that 0.1, 0.2, the distance between them, will it be called another name? No, it will be called wavelength. Okay, so that's for wavelength. But what about frequency? What does frequency mean? Can you just guess what does it mean? You're right. Well, frequency is just the number of waves that pass a point in space each second. That is the definition of frequency. Well, what about the units or the symbols that we write for them? Well, to abbreviate wavelength, we're going to use the symbol lambda. It looks something like that. That's wavelength. What about frequency? Well, frequency looks like almost like a V, but it has a small tick in here. Let me make it shorter, and a small circle in here. That's for frequency. Okay, we're talking about wavelength and frequency. Energy, everyone knows what is energy. What about light? What is light? Now, we're not talking about light only, we're talking about the speed of light. So what is the speed of light? You're right, the speed of light is just 3.0 multiplied by 10 power 8 meters per receptacle second. So that's the speed of light, and it's abbreviated as C. What about that number? We're going to talk about it later. Okay, so let's go to speed of light. What is the formula of speed of light? Can you guess? You're right. So the speed of light, when we're talking about light, well, light has what? It has a wave. So we need a wave. And inside a wave, what do we have? You're right. We have wavelength and the number of waves that pass a point in space each second. What is that? Frequency. So you can guess from all of that speed of light is simply the formula is speed of light equals frequency multiplied by wavelength. So that's the formula of speed of light. Now you can see that the relationship between the frequency and wavelength and the speed of light, it is inversely proportional, and that graph can prove it. Okay, so now let's go to that point of energy. Now, when we talk about energy, we talk about the formula of energy. What is the formula of energy? Well, the formula of energy is simply Planck's constant multiplied by frequency equals energy, and energy will equal to Planck's constant multiplied by speed of light divided by what? Wavelength. You're right. Okay, so what is Planck's constant? Well, Planck's constant is simply h equals 6.63 multiplied to the negative of 64 joules per second. So that's Planck's constant, 6.63 multiplied by 10 power negative 64 joules per second. So that's Planck's constant. Now Planck, the scientist, has said that the energy in an electromagnetic wave is inversely proportional to its wavelength and proportional to its frequency. So he said that about what? About the energy. So that's just about the frequency and wavelength and energy and speed of light. But that's not all about AP chemistry. We need to give examples to solve so everyone can understand what we're doing here. Because what is the reason of learning all of that if we can't just solve problems with it? Well, let's start with our first example. Well, I have it written in the paper, so it's going to be like that. The question says, what are the frequency and the energy of blue light that has a wavelength of 400 nanometer, and they gave us Planck's constant. Okay, now you gotta remember something in AP chemistry. You should always give yourself 20 seconds at least to read the question twice or 3 times. Because usually, if you know the question as if it's like your name, you know, like perfectly 100%. You're going, for example, read, okay, what are the frequency and energy? Finish. You're going to read that, then you read the word 400. You don't know what is the 400, like the unit, and what is about the 400. So you're going to take the units and just like those any units that you've chose them by looking at it and solve. And at the end, you know that concept and you know you can solve it correct. But then it turns out that there's different units that you need to convert to. So you're going to get like a whole mark gone from you. So that's step 1. Then second step that we need to do is always write down what's known and unknown. So let's start. Again, let's read the question. What are the frequency? They said frequency. So when they say what are the frequency, it means they don't know what is the frequency. So we need to write frequency equals unknown. We don't know what's the frequency. What are the frequency and the energy? Also energy. We don't know what is energy here. Unknown. So what is the frequency and energy of blue light that has a wavelength of 400 nanometers? So he said blue light, okay. So now blue light. Now he gave us what? He gave us the wavelength, which is 400 nanometer. And of course, whenever you talk about that lesson in AP chemistry or when you're doing the quiz, you should always know Planck's constant. Well, usually in the quiz, in the AP chemistry quiz, they will always give you the Planck's constant, the number of Planck's constant. But it's better to memorize. You don't know, maybe one time they decide not to put it. Okay, so that's what we know. And of course, to solve that, what formula should we use? You're right. We'll use that first formula and the second formula. So let's start. Let's start calculating. Okay. So which formula do we start with first? If we want to know what is the velocity. You're right. So to know what is the frequency. So to know what is the frequency, we're going to use that formula. So the first thing we have speed of light. It's going to equal to 3.0 multiplied by 10 power 8 meters per receptacle second. So that's a receptacle second. It's just a second with the power of -1. And that equals to frequency. That's unknown. That's why we write the symbol. Multiplied by wavelength, which is known as 400 nanometer. But can we solve that formula like that? Like we don't have same or similar units that we can cancel? You're right, we can't. So how can we remove that? Well, we can convert it to meters and put 400 meters multiplied by 10 power -9. That's much better. So after writing that, what will happen is that we can cancel the meters out. So whenever you want to put, for example, the number of nanometers into meters, you write, for example, the number here and write meters, then multiply by 10 power -9. Okay, so we're done with that. We'll do the math, so the meters will cancel each other. And how can that happen? Of course, we need to divide them. So we need to divide 400 from that side. Of course, we're doing algebra. And dividing it from that side, of course, we're going to have the meters here. Let's cancel this out. The meters here. Let's cancel this out. We're left with receptacle seconds. Okay, beyond that, we'll do the math. And the answer will be... Okay, so let's write the answer. Here, frequency will equal to... The answer after of course doing the math, I don't want to write all on the calculator because it take lots of time and we'll waste it. So it's going to be 7.5 multiplied by 10 power to the 10 power 14 receptacle second. So that's the answer for frequency. What about wavelength? Well, wavelength, we already knew it. So wavelength equals to, we said 400 nanometers, let's say meters, multiplied by 10 power negative 9. Now energy, we still don't know that. So how can we solve for energy? What formula can we use after we use the first formula? But did you know why did we use that formula of the speed of light? You're right, because we can't solve the second formula without knowing the units of frequency or the number of frequency. So that's why we started with that formula. Okay, so let's solve now for energy. We're going to write energy. Okay, so going to write the second formula. Energy will equal to H times V. So that will equal to solve that, of course you need to replace the units. So to solve that, we're going to write what we know. H is going to be what? You're right, Planck's constant, which is given 6.63, put it in parentheses, multiplied by 10 power negative 64 joules per second. And then we're going to multiply that by the number of what? By the number of frequency. So what is the number of frequency? You're right, 7.5 multiplied by 10 power 14 receptacle second. So that's for the first part of solving what? Solving for energy. Now of course we need to write now down so we can fit everything together, or delete that part. I mean erase that part. Okay, so we'll do the math, and after doing the calculation we're going to get the answer of course you don't need to waste time, so I wrote the answers on the paper. We're going to get the answer of 49.725 multiplied by 10 power negative 20 joules. And why does that happen? You just cancel seconds with seconds. Okay, so just ignore that. We're going to cancel seconds with seconds, and we're left with what? Joules. So the answer would be in joule. Well, in the question, as we read, we can see we solved everything correctly. But now, a better way of solving that, okay, we got the energy. We don't want that big number. Like, how can we solve with a big number? So to solve that, it's just simply, we're going to round that. And of course, if we round that, it's going to equal just to 50. So the answer will be 50 multiplied by 10 power negative 19 joules. So that's simply the answer. And of course, this is how we learn about chemistry, just by doing questions and solving them. Okay, so that's all about our lesson for today, and I hope it is useful.